All right, guys, we are live. Welcome. It's Friday. Woohoo! All right. Today we're going to finish off our chemistry. Oh, my video hasn't started yet. There we go. That's better. Today we're going to finish off chemistry. And we are going to focus on the thing that I think you guys go, oh, I can't do this. I can't. Well, don't panic. Don't panic. We're going to be okay. All right, guys. So I see some of you weren't here yesterday and some of you are new. Thank you so much for dropping me DMs and PMs in the chat. Okay. So let's quickly think about what we did this week. We, last week and this week, have been looking at basic chemistry. Okay. So we revised the periodic table. We made some friends with it. Okay. And then we started looking at bonding. So molecular bonding and ionic bonding and metallic bonding. Okay. And then we looked at physical changes and chemical changes. And yesterday, you guys all got terrified because I started putting in balancing numbers. Okay, now as I explained to you yesterday, before we get to balancing, I'm just going to quickly go over the work that we didn't finish yesterday. Just give me a moment to get the right view going. And to skip all the way to the slide that we need. We did all of this. We did all of this. Did all of this. Here you guys got really terrified, but we'll be okay. Endothermic, exothermic, we spoke about that. Okay, here is the stuff we missed out on yesterday. Okay, so the law of conservation of mass. It says that all substances in a closed system remains constant no matter what processes we're acting. Oh, you guys are on me, hey? Hang on, find the textbook. Oh, I have awesome news. I went onto Snaplify this morning, and on Snaplify, I found the Mind Action series. I found the Oxford textbook, the one that I normally use. I also found the Study and Master. Okay, so from next week, I'm going to put the pages for all the textbooks, okay, on there. So guys, Snaplify, snap with 2 P's. Okay, I'll put it in the chat. It's Snaplify, all right? Now, very, very cool. Because of lockdown, they have made all the textbooks on Snaplify free for the entire year. Like, seriously? So you can go and download all the other textbooks, okay? And you then have some extra reading and some extra exercises. I think this is such an amazing thing that they did. Okay, so snap with 2 P's, Lify. All right, so guys, go check it out. You can get maths on there. There's life sciences on there. There's so many textbooks on there. Okay, so please go check it out. So for those of you in the Oxford dictionary, they've got an Oxford dictionary on there for science too. Oxford, we are on page 132. Okay, 132. Right. So, conservation of mass. I want you to think about when you are baking a cake. Oi, now I just lost all the boys, hey. When I bake a cake, I have the packet or the flour if you bake it from scratch, okay? And I say I need 2 eggs and I need a cup of milk, okay? and I beat them all together in a bowl, and I get a cake out on the other side. Okay, now, if the recipe says I need to add 2 eggs, I can't not add the 2 eggs and hope and pray the cake is going to be the way it should. Okay, so everything I put into the mixture, no more and no less, I get into the cake. Okay, don't you get better before you get the actual cake? Yes, Matthew. Okay, but think about it this way. Think about it this way. If the recipe says 2 eggs and I only put 1 egg in, I'm not going to get the cake I want. Okay. And guys, as weird as this sounds, this is how chemical equations work. Everything that I start off with, I also have to get out. Okay? I can't have something in the beginning and then not have it at the end. I can't need something at the end and then not have it at the beginning. Okay. And that is what balancing is all about. And balancing is about this concept here, that the total mass, as well as everything else, stays the same. Okay, right. So the mass of the products equals the mass of the reactants. It's like a scale. Whatever I start with, thanks, Ruben. Whatever I start with, I will get out. It might look different because let's be honest, a cake does not look like the stuff I put in first. Okay, the batter doesn't look like the stuff that I put in, and the cake doesn't look like any of those. Okay, they might look different, but everything I put in, I get out. Okay. Now, constant composition. Now, whether or not, yes, we are doing balancing. Calm down, calm down. Constant composition, whether you realize it or not, we've already done this. Remember when I explained to you guys electron transfer and how, for example, sodium has 1 valence electron, so it can give 1 valence electron. Chlorine wants 1, and so sodium and chlorine will always react 1 to 1. You're not suddenly going to have 1 sodium and like 4 chlorines, okay? There's not enough moolah in the system to make that happen, okay? Right? So the law of constant composition. Moholo, in which textbook? The law of constant composition tells us exactly that. Okay? We just now put it in words. Moholo, in which textbook? If you guys hear any of the dogs, there's one dog by my feet dreaming, so she's making weird noises. Okay, Teboho, can I carry on? Study and master. D, where are you? I think it was 166. Okay, guys, I'm carrying on. Here we go. So, constant composition simply says that the atoms always bond in a specific ratio. Okay, and like I said, I know it sounds weird. I know, but we did this. We did this when we looked at how sodium and chlorine make sodium chloride and how magnesium. I don't have a Doxke Inza book. I do know that I'm busy downloading one like via. So I will add those pages in as well. Okay. Look for balancing of equations, dude. Right. So we've done this. I know this looks weird, but we have done this. Okay, so keep this in mind, as well as the law of conservation of mass, no? And let's look at how these two allow us to balance equations. Okay, guys, I didn't pick a lot of equations, okay? I picked simpler ones, right? I will give you a couple to practice. If we don't get to giving you the answers at the end for those, then I will start with that on Monday. But like with a lot of things in life, okay, you need to struggle with this a little. Okay, Miss P, I'll definitely get it downloaded so I can give you guys those pages as well. Doxkey Inza, however, is not on Snaplify, all right? But I will make sure I get that for you guys. Okay, promise. I've got a whole weekend. Okay, right. So let's go to balancing. Okay, deep breath. We can do this. Lynette, I don't have a Doxkey Inza book, so I don't know in which one. Okay, right. So balancing, thinking caps on, but calm thinking caps. We are not going to panic. All right. So I want you to write these steps down. Matthew, in the Oxford, we are on page 138. Okay, so I want you to write these steps down. They are different in the textbooks, okay? But these are the steps that I firmly believe makes it easier, okay? So step one, you write down the equation. You don't worry about, Ruben, I skip all the stuff that I know you don't need, because I know if you have to read through all of them, you're going to get bored and fall asleep. Okay, so you write down the unbalanced equation. You make sure your chemical formula are correct, and you add, as far as you can, the phase symbols. So remember, for phase symbols from yesterday, you put in a bracket, and it's a G for gas, a L for liquid, a S for solids, and AQ for aqueous. Yes, Sandra, I give you what you need to do the work. You need to remember that the textbooks often give you more information and more of this and more of this, and this is cool, okay? What I am focusing on is the work you guys need, the knowledge, the content you need to be able to do chemistry, okay? Because ultimately, I think you guys get so bored with chemistry because there's so much theory and not enough doing, which is why you struggle with it, okay? And that's why today, this is what we're focusing on. Guys, if you can get this, sure, like nothing can stop you, okay? And Sandra, I remember yesterday you were saying, look, I struggle to split them and don't worry, okay? If at the end of the day, you still struggle with it, you send me a DM or a PM, let me know and we'll fix it, okay? Right, guys, so step one, I see a hand up, you need to type me a chat. Step two, now I know this sounds crazy. Nearly can't see what is written. Can anyone else not see what is written? Nelly, is it because you're not tuned in on the video? Okay, Nelly, you need to make sure that you've got your screen on. Okay, but I promise that all of this will be on the website. Of course I'm doing an example. What you talking about? What you talking about? Of course. Okay. Yeah, might, but let me look after that. No, it's because you have covered the side. Me or... Okay, here we go. Here we go. So you draw a table. Thank you, Carolina. And then you balance the equation. Okay. These are the 3 steps you follow to balance equations. Now we're going to switch to the whiteboard, okay? And we're going to do this. And I'm going to purposefully focus on speaking slowly. Because I know my ADHD makes me like talk really fast and then I lose you guys, okay? So my focus is going to be to talk slowly. Yeah, I know, Matthew, okay? And we're going to do this step by step. Okay. So I want you guys all to write this equation down. We looked at it yesterday, and I think this equation is the first one that you all know, the rust one. You guys kind of went, oh my God. Okay, ma'am, do you really have to add the phase symbol? It's not necessary in grade 10. It's not necessary in grade 11. And then you have to do it in grade 12. Jared, yes, eventually balancing becomes so easy that you don't have to do the table, okay? I do the table so that you guys realize that you need to go back and forth and back and forth, okay? All right, guys. Oh, Sandra, I understand. Okay, you can leave them out, guys. What's the go for? It means it's a gas. Erin? No, not Erin. No, Erin, wait. We're going to do this together. Gordley, yes, liquid water is a liquid at room temperature, but when we do this reaction, a lot of energy is released, okay? So when the energy is released, we end up having water vapor. Ruben, I doubt it, but okay. All right, so we've got this one, right? Now, if this is easy for you, then I am so glad, okay? But I know a lot of this terrifies a lot of you, okay? And it shouldn't. It's just like the periodic table, okay? It's your friend. All right, so we're going to do this slowly. Let me get a whiteboard. Okay, so the formula was H2, which is a gas, plus O2, which is also a gas, and it combusts and forms H2O. Okay. H2 because it is a diatomic gas. O2 because it is a diatomic gas. And H2O because that is the formula of water. All right. So the first thing we do is we draw the table. And I'm quite lucky. I have figured out how to make this ruler thingy do cool stuff. Diatomic, Nelly, diatomic gas, there are 7 of them. A diatomic gas is a gas where in nature that element prefers to be a gas where it is two atoms bonded together like that. There is 7 of them. It's like a pair. Good. So will the same equation substance react differently, different temperatures, stuff and doesn't say? Yes, Ruben. Okay. The states also depend on the reaction conditions, the temperatures. Okay. So I've got a table. Now, in my table, my one column is for the reactants. The other column is for the products. And in this first column, I write down all the elements that I have. So I draw my table. The one column is for reactants. The next one is for products. And my first column, I write down the elements I have in the reaction. The next step is to count how many atoms of each element I have. I'm going to say that again. I count how many atoms of each element I have. So remember, the arrow splits the reactants from the products. Okay, you can use any table, Brooklyn. Okay, so I have H2. Okay, that means I have 2 hydrogens on the reactants side, and I have H2, 2 hydrogens on the product side. On the reactant side, I have O2, so I have 2 atoms of oxygen, but on the products, I only have 1. Okay. The reason I say this reaction is not balanced because I don't have the same number of oxygens on the reactant side as I have on the products side. Okay, you see that? I started baking a cake with 2 eggs, but I'm only expecting 1 egg to be in my cake, and that's not going to happen. Okay, so how do I fix this? I need to get more oxygens on the product side. So I can multiply by 2. Very important. Okay, Miss P, then just ignore my cake stuff. Okay, very important. I cannot go plus or minus. I can only multiply. Okay, so if I multiply by 2, it means I write a big 2 in the front. If any of you write little numbers at the bottom over there, I'm going to find you and hurt you. Okay? I cannot change what H2O looks like. Okay? I can only say I'm going to have 2 H2Os. Arthur, I'm multiplying by 2 because on the reactant side, I have 2 oxygens. Ali, my pleasure. On the reactant side, I have 2 oxygens, but on the product side, I only have 1. Okay, we have to have the same number on both sides. Okay, I can't change what water looks like, so I can only write big numbers in the front. Okay, so now by putting that 2 there, can you guys see I now have 2 oxygens? Ma'am, we put the number in the front only if we multiply. Yep. Okay. So by multiplying by 2, I now have 2 oxygens on my products. Okay, so that's fine. Yes, Jared. We now have 4 hydrogens. 4 hydrogens. I don't have 2. I have 4 hydrogens. Arthur, how? H2, but I have 2 of them. So it's 2 times 2, which gives me 4. You can't add or change subscripts. Yes, Gloria, you are not allowed to add or change subscripts. Okay, so now I've got 4 and 2. That's unbalanced. But now I can multiply by 2 here. So multiply by 2 there. 2 times 2 is 4. And now this thing is balanced. I have 2 times 2, which is 4 hydrogens. And I have 2 oxygens. On the product side, 2 times 2, I have 4 hydrogens. And 2, remember there's a little 1, 2 times 1 gives me 2 oxygens. So now I can say that this is a balanced reaction. Okay. Can you guys see why I draw a table? I draw the table because when I change one thing, it always seems to change the other thing. And what I find happens is that you guys fix one thing, but you forget to change the other thing. Carl, I get it. We're going to do a million examples. Okay. And the reason why, okay, so you multiply the reaction with the product until you get the answer. Yes, dude. You multiply and fix and play until everything on the left is also on the right. Okay. A lot of you would have done this, the right side, but would have forgotten to go back and fix the left. And that is why I use a table. So that I can see I need to go backwards and forwards or forwards and backwards. Okay. This is why I do it in this way. And when you do it enough times, you start to see patterns. And eventually, yes, Letabo, exactly like maths. Okay? When you start to see the patterns, you can drop the table. Okay? But the table gives you a place where you can double check. Yes, I'm going to do another example right now. Let me go back to, I'm going to come back to this. Don't shout at me for changing the board. Okay, so we did this oak. Oh, ma'am, sure. Why did you have to give us one in words? Ah, it's okay. Don't panic. know what each of those are, we can do this. Okay, so let's go back to the whiteboard. Iron, chlorine gas, and iron 3 chloride. Let's hope I remember that all the way to the whiteboard. Okay, we got the whiteboard. Guys, I'm going to move up. Here we go. So now this one's got one extra step to it. Iron plus chlorine gives me iron 3. Corley, what do you need to write down the previous one? Corley, which one do you need to write down, sweetie? The previous one. Okay, guys, I'm just going to pop over because it is in words, Carl. So, Corley, see if you can take a screenshot of that. Guys, remember, okay, I will put all of this back together for you neatly in notes, step by step by step, and that will be on the website. It will be on my Facebook. I might even be really nice and put it on Insta. I have no idea how I'm going to do that, but I'll try. Okay. Ma'am, would they give us an equation in words in your exam? They could. And that's why I'm doing it. Okay, Corley, you good? Corley's got the weirdest surname. Thank you for using the table. Nelly, I cannot tell you how long it took me to figure this out, okay? And when I got it, I was like, oh, duh. Okay, and why not share that with you? Okay, so iron, element on the periodic table. It's a metal. Most metals are solids at room temperature. Okay. Chlorine. Chlorine is in group 7. And you will remember that it is a diatomic gas. Carolina, I hear you. You can go and check on YouTube. You probably had a bad connection. I think everybody else heard me okay. So Carolina, you can go back onto YouTube and watch the video again. Okay. I did that yesterday after I had you guys because it was such a cool lesson. I watched it again. All right. Iron 3 chloride. That 3 means it is Fe3 plus. Okay. Chloride is Cl. It is in group number. Adrian, yes, it is a diatomic molecule. Diatomic gas, same thing. Okay. Chlorine is in group 7. It has 7 valence electrons. It wants 8. So it goes and steals 1. So it becomes -1. Okay. Not quite, -1. Man, when we get words, we must just convert to symbols. Yes. Of course, dude. Okay. So, how many chlorines do I need for 1 iron? Miss P, you can't balance it if you don't. Come on, guys. How many chlorines do I need for 1 iron? If it's -1, and plus 3, and it needs to be 0. Yes, I need 3 chlorines. Okay, Arthur, I got you. Okay, I need 3 chlorines for every 1 iron. Is everybody okay with that? 3 chlorines for every 1 iron. Okay, you don't need to know this, okay? But most salts are solids, most. But if you don't add that, that's okay. Okay, all right. Now we draw our table. I'm going to get a little lazy. I hope I can draw a relatively straight line. Nunk, nunk. I have iron and I have chloride. I have reactants and I have products. Yes, you could just swap the numbers. If that helps you, you can just swap the numbers. As long as you know why you swap the numbers. Okay. So, Tomelo, I know on YouTube you can't ask questions. It's because even though it's streaming live, I can't have the YouTube window open and the Facebook window open and you guys open. Okay. I'm going to tell you about a really cool thing for next week, I promise. Okay. Miss P, if you got to this thing, don't worry about the pull down crossover. Okay. They have a shortcut way of doing it. Don't panic about it. If you can get from Cl-1 and Fe3+ to FeCl3, you are golden. Okay. We have 1 iron and we have 2 chlorine. Nah, we good? On the products side, we have 1 iron. Oh my golly gosh. We have 3 chlorines. So the ions are balanced, but the chlorines are not. Okay. Now, just like I multiplied earlier to make them be the same, I'm going to multiply them now to make them be the same. So, can you get negative transition metals? No. Okay, so I'm going to times the products by 2 so that I put my big 2 there. So now I have 6. What do I do to the 2 to make it a 6? You were right. There we go. Okay. This here becomes 6, but now I need this guy to be 6 as well. So I times it by 3. Where do I write the 3? In front of the chlorine. Okay. Now I've got to check because now obviously with my iron, here something would have changed. So when I put this 2 here, I now have 2 iron atoms on the right, 2 on the product side. On the reactant side, I still only have 1, and so I am going to multiply by 2. Sandra, yes, in essence. Okay. Can we see there? Was that so bad? If you use a table, why did we multiply Fe at all? Because our chlorines were not balanced. Why did I cancel the 1? because the second I write this 2 here, that 2 applies to that FE as well. And so this one is multiplied by 2 as well. And therefore I cancel that 1 out. I often do it here as well. I cancel out and I write the new number. So here I would cancel out and write the new number. And that helps you immediately see, hang on, this is now 2 and this is only 1. Which helps you go back and forth and back and forth and back and forth. Nelly, thank you very much for the compliment. I really appreciate this. All right, guys, so why were we terrified about balancing again? I didn't think you would. Okay, so I want to give you a couple of examples to go and practice at home. Ollie, I promise I will pull it out Monday. Okay, but I have really, really awesome news that I haven't shared with you guys. Okay. Come on, man, you got it. Okay, so Arthur, I'm going to give you the examples to try. No, wait. There we go. Sure, man. You gave all of us as 2 words. I know, I thought I'd challenge you. Come on, I know you can. Okay, so now, we have been really struggling in Zoom, okay? Like really struggling. We've been trolled, we've been bombed, we've been, I don't know, there's like so many words. So, last weekend, we spoke to, I say we, Zoom bombed is when you get kicked out of your own lesson. Okay, so we spoke to Microsoft. Now, Microsoft has got a program called Teams, okay? The problem with Teams was before is that we couldn't get you guys from all over into the same team and make it work, okay? It just couldn't. So what Microsoft has done is Microsoft has rewritten Teams so that we can keep you guys safer. Okay, Jared, don't give away the answer. Shush. Okay, we can keep you guys safer, right? But still do this. So from Monday, we are not going to use Zoom. We are going to use Microsoft Teams. Why safer? Because, like, you can ask the moderator, okay? The comments in some of the other groups have been horrific. Okay, whoa. If you don't have Microsoft, you can still join online, okay? But you can download Microsoft Teams, okay? Don't panic about logging in and stuff like that, okay? Don't. Just like you've been getting a Zoom code to join this lesson, you're going to get a Microsoft code to join the lesson. Tebogo, I see a hand up. Okay. So, whoa, it's not going to change for you guys. It's going to be exactly the same. All right. But now, I'm going to give you the email address or the website that you just need to make sure that you are registered so that you can get all the information. So make sure you are on registrations.africateamgeeks.co.za. Okay, you fill in a little form. with your email address or your WhatsApp or whatever, okay? And they send you the correct links, okay? Right. Then I also really would like you to fill out a Google form for me, okay? Completely voluntary. I sent it in the chat as well. Completely voluntary. But I would really like for you guys to do it because we get some feedback from you, okay? What can we do better? What do you need help with? Who are you? Where are you? Okay, right? So I sent you the Google form, okay, in the chat as well. I'm going to put it on Facebook. I will put these on Insta so you can get it, okay? I'll try, wait. Copy hyperlink, paste hyperlink. That better? No, it doesn't want to. I know, Miss P. So, Miss P, you need to make sure that you can join us. My Instagram, Informelen Tutoring Services. I ran out of being creative. Yes, Matthew, we're not going to use Zoom. We are going to use Microsoft Teams. We're still going to do this, guys. I will still be teaching you. I don't have to go back to work until lockdown's over. It's still going to be me. It's still going to be us. Okay, you're still going to be able to talk to each other. No, this is for all of it. Okay, all the lockdown e-schools. My Facebook is the same. All the lockdown e-schools is moving onto the Microsoft platform. We will send you links for the Microsoft Teams. It's for all the subjects. Okay, guys. Yes, you can get more notes. Go look africateengeeks.co.za. Exactly, the trolls won't come, so we won't have to be so difficult. Will the links be on Facebook? Yes, my sweetheart, I will put them on my Facebook page. Informelen, still the same time, Informelen Tutoring Services. Yes, Tyler, that's perfect. Everything is going to be moved out of Zoom. Guys, we don't have classes over weekends. You don't have Facebook? Register on Africa Teen Geeks. Microsoft Teams. Yes, Tyler, I know. I don't know. Okay, guys, our time is up. We have kicked our asses for balancing. Right, I am proud of you. Go have a fantastic weekend. Okay, go rest. I promise I will see you again on Monday. Bye.